What is internal deformation in the cryosphere? Have you ever wondered how glaciers and ice sheets manage to flow without breaking apart? The answer lies in a fascinating process called internal deformation. Internal deformation in the cryosphere refers to how ice within glaciers, ice sheets, or sea ice changes shape and flows due to various stresses acting on it. This happens without the ice fracturing or breaking apart. Inside the ice, at a microscopic level, the ice crystals are constantly adjusting and moving. This movement allows the ice to slowly change its form over time. In polar regions, ice faces multiple forces, including gravity, pressure from the weight of overlying ice, and environmental factors like wind and ocean currents. These forces lead to a process known as ice creep, which is the slow, continuous movement within or between ice crystals. As glaciers and ice sheets flow downhill or spread out, they shape the surrounding environment and influence ice dynamics. The rate at which internal deformation occurs depends on several factors, including temperature, the size of the ice crystals, the amount of water within the ice, and any impurities present. Warmer ice behaves more like a soft material that can deform easily, while colder ice is more rigid and resists deformation. Think of it like a chocolate bar. When it warms up, it softens and becomes easier to bend. When it cools down, it hardens and becomes more difficult to shape. As temperatures drop, ice becomes less able to deform internally and acts more like a solid block. Internal deformation is different from other forms of ice movement, such as fracturing or sliding at the base of glaciers. It is a fundamental process that helps ice masses in the cryosphere flow and respond to changes in climate and the environment. Understanding how internal deformation works is essential for predicting how polar ice will evolve and its potential impact on global sea levels and climate systems. In practical terms, internal deformation affects how ice redistributes mass within ice sheets and glaciers. This redistribution influences the stability of these ice formations and contributes to the development of features like crevasses and ridges. Additionally, it plays a role in the seasonal and long-term dynamics of sea ice, affecting how ice cover reacts to temperature changes and mechanical stresses in polar oceans. So, the next time you think about the majestic glaciers and ice sheets of the polar regions, remember that internal deformation is a key player in their movement and transformation.